All right, good evening and welcome back to College Algebra here. So we were talking about parabolas yesterday. And yep. And now we get to do something that's a little bit harder. Okay. So there are a couple of different ways that we can figure out what the vertex is. And depending on how the problem is presented, you want to take the easier of the two ways. Okay. Technically, you want to use the method that they tell you to use, but part of this is learning which ones work for you and choosing the appropriate one based on the problem. All right. So even though I know they're going to tell you to use one or the other, I know you're going to favor one particular one, and I know which one that's going to be. Okay. So before we actually hit this problem, what I'm going to do is I would like to say something like, yeah, why don't we just try like an x squared minus a 10x, and I will say, why don't we go ahead and say something like plus 26 here equals y. Right? And if you remember, back in the day, what we did was, if we wanted to complete the square, all right, we identified the middle term, we divided it by 2, and now we squared it. All right, and now what we have to do is we are going to, actually I'm going to change this to a 4. What we have to do is we're going to take our 25 here, we're going to add it. So we're going to have x squared minus 10x. We're going to add 25, and then we're going to subtract 25. So that's just 0. But what we're going to do here is we're going to go ahead and group them so that I've got my completed square part, and then I've got the rest. So, and the completed square, we get the x minus 5 squared, and then we have minus 1 here. Right? Minus 24 plus 20, minus 25 plus 24, we end up with a minus 1. And now, right, we could look at this and we could say, hey, if I asked you for the vertex of this parabola, it would be hard to tell what that was. But now we've completed the square, and now it's pretty easy to tell what that is, right? The parabola is going to be 5, -1, right? That's the vertex. And then we can answer all the other 9 or 10 questions that they would have for us, okay? There is another way, okay? Let's see, if I end up with this guy here, and I set x to be, right, negative 10/2. Where'd the negative 10/2 come from? Well, that's my b/2, isn't it? Right, that's my b/2, and that's going to give me 5. If I plug 5 in here, then that's how we could figure out where the center is going to be, right? We would be okay with this. Even though we already know it's 5, if I go ahead and I plug 5 in from over here, right, we're going to get a 0. That b/2, this negative b/2, that's not a mistake. That's not a coincidence. The vertex is always going to be negative b/2. All right. And then f of negative b/2. So whatever number this is, you plug it into the function, and that'll tell you the vertical part of it. Okay, and it all comes from this completing the square business. Okay, now you don't have to remember that. Okay, all you have to do is remember that our vertex, and I say negative b/2 because when I completed the square, all the problems I did, this was a 1. So I lied a little bit. This is b over 2 times a, b over 2 times a, because that'll take care of, like, what if the first coefficient isn't a 1? And I can't complete the square very well. Well, one of the things we do is we divide out by a and then put it back in at the end. So my negative b over 2a is actually the place for the vertex. Okay, so this is yet another formula that you'll remember. So vertex is negative b over 2a, and then f of negative b over 2a. Right? Now, I did always resent having to know this. Okay, so I don't know what we're going to be dealing with yet, but I remember learning this, and I remember resenting the fact that I was like, surely there must be an easier way. There is, but you have to wait for calculus in order to get that easier way. Okay, but for algebra, this is what we're dealing with, is negative b over 2a, and then we plug that formula in. Okay, so if I went back to my original thing, right, with my x squared minus 10x plus 24, right, and I plug in, right, negative b over 2a, vertex is x equals, well, that's going to be negative, and then my vertex is negative 10 over 2 times 1. That was going to be 5. And then we plug in 5 for here, and that's going to be my results. We're going to have 5 squared minus 10 times 5 plus 24. So I have 25 rather, minus 50 plus 24. Well, 24 and 25, that's going to be 49. 49 minus 50 is negative 1. So vertex 5, negative 1. And I didn't even have to complete the square to do it. Okay. So, well, how's that going to help me? Well, some problems you don't want to complete the square on, because honestly, you only really want to use complete the square if you have no other options, because it's the longest one of all of them. Okay. So if I have this thing here, if I have 2x squared minus 36x plus 57, okay. Oops, I don't want that. Why did it give me this? All right. So if I've got my f of x is equal to 2x squared minus 36x plus 57, the vertex is negative b over 2a. That's my x value. And then my y value is f of negative b over 2a. We're just going to get a number here and plug it in. Okay, so we're going to say, well, negative b over 2a. So x is equal to negative 36 divided by 2, and then a is 2. Okay, it's negative b over 2a. So we're going to get a positive 36 divided by 4, which is 9. The x part of my vertex is 9. Now we're going to plug this in and see what happens. Okay, so f of 9 is equal to 2 times 9 squared minus 36 times 9 plus 57. Okay. So let's see, 9 squared is what, 81? And 2 times 81 is going to be 162. I think 36 times 9 is going to give me 144. And we have plus 57 here. Right, because this is 4 times 9 times 9. It's 2 times 9 squared. Oh, no, it's not 144. It's bigger than that. It's 18 squared. That's going to be 324 or something. 36 times 9. Yeah, 324. Okay, that's better. Let's get rid of that. Okay, and that is 324 here. While I have this up, we're going to take 162 minus 324 plus 57. Negative 105. So my vertex is 9 and negative 105. Delightful. I'm sure they've got more for us in a moment here. Okay, so we are at 9. It was negative 105, wasn't it? All right. Oh, that's all they had for us. Well, let's do another one. Okay, so here we have 2x squared minus 32x plus 101. Okay, so negative b over 2a, right? X equals. So we have negative 32 over 2 times 2. So that's 32 over 4. That gives me 8. So the x value of the vertex is 8. Okay, we're just going to plug it in now. We're going to say 2 times 8 squared minus 32 times 8 plus 101. And figure out what that is. So we have 2 times 8 squared minus 32 times 8 plus 101. Negative 27. Vertex point, 8, negative 27. I can show you this. Okay. Let me show you 2 more. Well, I'll wait for just a moment, but I'll make sure to show you 2 more tricks for this. So let's see here. Let's try another one. Let's go one forward here. See, now something like this, you really don't want to try to complete the square on this one. This is going to be a difficult problem to complete the square on. You got a fraction out front. Things get kind of awful with that. It's really not the most enjoyable problem you want to deal with. Okay, so I got negative 1/3 t squared plus 8t minus 9. Okay, so what I'm going to do is we're going to say, well, x equals negative b over 2a. Notice I'm writing the formula every time I'm doing one of these problems. That really will help you memorize what we're doing here. Okay, so we have negative 8 divided by 2. We have a negative 1/3 here. Okay, so we have a negative 8 over negative 2/3. Okay, let me write this a couple of different ways. Okay, so we have negative 8 over negative 2/3. One way, right? One of the things we do in intermediate algebra is that we simplify complex fractions. That's what this is. So this is 3 divided by negative 2, 3 divided by negative 2. Here's that baseline. This cancels, right? And we end up with 24 divided by negative 2, and that's going to be positive 12. You see, that seems kind of nice, but I'm a little confused because I don't like it when I've got a regular number divided by a fraction. Okay, so we've got, this means division, right? 2 divided by 3, that's 2/3. So do you remember what we do when we say negative 8 divided by negative 2/3? We invert and multiply, right? That's how we deal with fractions. Or if you have other ways, right, put that over a 1, right? There's like a weird kind of circle thing that you do with the crosses, and I don't know, but if that's the way you learn, don't let me stop you, okay? If that's the way you like to do your fractions and you learn like a crisscross thing, you go right ahead and do it. All right, times 3/2, because that's what dividing by a fraction means. It means flip it and then multiply. So we get negative 8 times negative 3, that's 24 divided by 2, and then we end up with 12. Okay, so either way you do this is fine by me. I don't have a preference. Okay. I would prefer that you didn't have to reach for the calculator every time, but you know, for some of the tricky ones, I'm not going to pretend that I wouldn't do it. So, you know, there we have it. But for some of them, I would try to practice. You can check yourself with the calculator, right? If we want to do that, just make sure you're using the parentheses. Otherwise, it's gonna think you meant something else. We have -8 divided by, that's the fraction, parentheses, -2/3, right? You can always double check, right? Just make sure you use parentheses in the right place, and that way it'll work out. Okay, but someday, maybe you won't be using the calculator to do that. Okay. So let's see here. We're not done yet because that's my x value. Okay, so the x value is 12. We have to figure out the y value. So that's -1/3, 12 squared plus 8 times 12 minus 9. Okay. So what is this going to be? It's going to be 144/3 negative plus 8 times 12, that's 96, minus 9. Okay. I know 3 goes into 144. It's got to be like what, 40, and then 48. 48 times 3 equal to 144. 12. Oh, that's a 2. Yeah, we're okay. And now the hard part. Okay, so -48 plus 96 minus 9. Okay, it's 39. All right, so my vertex, 12, 39. Okay, so the vertex is 12, 39. All right, let's try another one. Okay, this one's not as bad because it's halves instead of a thirds. All right, so we're going to have k of t is equal to -1/2 t squared plus 4t plus 5. And they want to find the vertex. X is equal to -b/2a. Okay. So we're going to say x equals -4, that's the b, divided by 2 times -1/2. What is 2 times 1/2? That's just 1. So we have -4/-1 is 4. Okay. So then we're going to plug 4 into this. Okay, so we're going to get -1/2, 4 squared, plus 4 times 4, because t is 4, plus 5. X, t equals whatever. Okay, so we're going to have -1/2 times 16 plus 16 plus 5. So that's going to be -8 plus 16 plus 5. What is this going to be? 21. Well, it's going to be 13, I think, right? It's -8, and it's going to be -3 still. 16 minus 3, 13. Okay. So my vertex, 4, 13. Let's try it out. Okay. All right, so that is that's the vertex formula. They asked us far fewer questions. Okay, that doesn't have to be there. They could ask us all the other stuff too, because once you know what the vertex is, all that other stuff gets unlocked. Okay. Oh, well, in this case, this is a good one. We'll do this one. No, we won't. There is no b, right? So when there's no b, what's going on? Well, in this case, we have 3t squared plus 0t minus 10. So my vertex, t equals -b/2a. It's -0 over 2 times 3. Well, 0 over 6, right? Negative 0 over 6, I don't care. That's just going to be 0. Okay, so we just have t is 0. If t were to be 0, what will my y value be? Right? That would be negative 10. Oops. There we go, minus 10. So that one was nice. Oh, see, now this one, you definitely want the vertex formula here. I would not want to deal with this one as as trying to complete the square. This is going to be difficult. Okay, I don't even think I want to do this one otherwise. But let's go ahead and take a look at this one. See, this is the nice case. This would definitely be use the vertex formula. Okay, so we have 0.5 or half, right? X squared plus 3.5 x's, and then c doesn't really pop into the equation too much, but negative 3.2. Okay, so my x is equal to negative b over 2a. So we have negative 3.5. This negative is a negative divided by 2, and we have a 0.5 here. So negative 3.5 over 2 times a half. It's 1. So x is still negative 3.5. Okay. Now we got to plug it back in. Okay, so we have h of x is equal to this horrible thing, right? So we're going to say h of negative 3.5. So we're going to go there. We're going to say this is 0.5 times negative 3.5. And you don't have to put the negative in when you do this one. Okay, when you put this in the calculator, you just say 3.5 squared, because you know that this is going to be a negative here. Okay, and we have 3.5 times negative 3.5 minus 3.2. Okay. So we'll go through and we'll do that. So we'll say 3.5 squared times 0.5. Oops, I want 0.5. About times 0.5. All right, and then we're going to have minus, because that's going to be a minus there. And I'm just going to save a little bit of time by taking 3.5 times 3.5. Right, and then minus 3.2. 0.2. There we go, and that was negative 9.325. So my vertex, okay, vertex is negative 3.5, negative 9.325. See if they ask us anything more. No, it looks like that's it. All right, well, 3.5 through 9.3. Okay. So we've got negative 3.5 and negative 9.325. Looks like 3/8. There we go. All right. Now we're back to doing this again. Okay, let's consider the function. Okay, determine whether the parabola upwards or downwards. Well, the leading coefficient is negative, so it's going to be negative. And now it's going to ask you, like, find the vertex. And now this is up to you. Since the leading coefficient isn't a 1, I would recommend using the vertex formula for this. But if you wanted to hold the negative 1 out and do this, complete the square, that'd be fine. Okay, so we're going to go ahead and we're going to say vertex is, what do we have here? We have negative x squared plus 2x. So we have negative x squared plus 2x minus 2. Okay, so we're going to say this is x equals negative b over 2a. So that's going to be negative 2, right? This negative 2 divided by 2 times negative 1. Those cancel. These cancel. We just get 1. X equals 1. So if I want to plug this into everybody else, right, we're going to say, okay, the y value is negative 1 squared plus 2 times 1 minus 2. Well, the 2 and the negative 2, right, those cancel. So I left with the negative 1. So our vertex, 1, negative 1. Now, graph opens downward. Oh, we have to check. Okay, vertex is 1, negative 1. All right. Determine the x-intercept. Okay. So this case, all right, let's draw it. Where's our vertex? Vertex is 1, negative 1. Which direction does this thing open in? Down. Does it make sense that there is no x-intercept here? Right, it's not going to come back up and hit this line. It's just going to keep going down from here. So in this case, there are no x-intercepts. All right, that can happen. All right, he's pretty happy with me. Y-intercepts. Now, there's always going to be a y-intercept, even though you think, like, wow, that's pretty far away. Like, y-intercept is all you have to do is set x equal to 0. Right? So if we want to go ahead and solve this, right, we're going to have, what's this, negative x squared plus 2x minus 2. We just set x equal to 0. We get 0 plus 0 minus 2. We get minus 2. They want an ordered pair. They want an ordered pair. So minus 2, 0. Right? When x is minus 2, y is 0. Now, x is 0. What am I doing? X is 0. Y is. There we go. All right, that wasn't making sense in my head. I was like, that ain't working. Good Lord. You think they would have given you like a better. Place the vertex. 1, negative 1. Curve opens down. And then we know another point, right? We know when x is 0, y is negative 2. So we're all set. And it's happy with us. Okay. See, it doesn't cross the axis. Oh, now they get to asking us all the other questions that could happen. Okay. So where's my vertex? It's at 1, negative 1, right? Vertex is 1, negative 1. So where's my axis of symmetry? So the symmetry is the line x equals 1. Okay. So axis of symmetry is x equals 1. Okay, oops, it doesn't like, it's not going to like that. X equals 1. Shoes has a, well, does it open up or down? Okay, it opened down, so this is going to be a maximum, isn't it? Right? It doesn't have a minimum. The minimum could be as negative as it wants, but the biggest number you have here, right, the number you'd least amount like to be in debt is negative 1. So as a maximum value, okay, looking at the graph, the maximum value of f is negative 1. See, but we already know that because we knew the vertex. Okay, right, the domain and the range. Well, again, the domain is kind of like a sucker's, right, a sucker's answer. It's always, unless we have a fraction or a square root, right, it's going to be everything. And the domain and the range, rather, well, if we look at the graph, right, it goes from negative infinity up to our maximum. Right? So again, they already asked us this question. Right? When they asked us for the vertex, they asked us this. So there we go. Okay. So like I said, I don't know if we need to answer every one of these questions every time, but it is good practice. Okay. Oops, I just went next. Continue. All right. So consider the function. Okay, again, same. Oh, good Lord, all of this. Thanks a lot. Okay, here we go. These are a little tedious, right? I'm sorry for that. I really am. But they are great homework problems because by the time you're done, you've answered everything 3 times. You will not forget this. Okay, there's my function. Right. So we're going to have to figure out the vertex. Okay, does it open up or down? It opens up. Okay, it's positive. Okay, vertex, x equals negative b over 2a. Okay. So we have negative 15 over 2 times 5. So that's negative 15 over 10. If I cast out some 5s, that's negative 3 halves. Okay, it's negative 1.5. Now we're going to put this into the formula. Okay, we're going to go ahead and put this into the equation here. So g of negative 3 halves. We're just going to go through. We're going to say 5 times negative 3 halves squared plus 15 times negative 3 halves minus 2. All right. And again, I wouldn't put the negative in as I was going to calculate this because I don't want to take the chance of not having the parentheses understood. So I'm going to say 3 halves squared times 5. And then minus 15, because the minus sign will float out, minus 15 times 3 halves. All right, and then subtract 2. Okay, so we have negative 20 and 3/4. Okay, so my vertex, negative, sorry. And just in case they might want this in a fraction, here's what you're going to do. If they insist on putting in a fraction, you see this math button here? And press that, and you're going to say, this will convert the previous number into a fraction. Okay, so negative 83/4. I know I told you that story before. Because I always remember my elementary school teachers telling me, you're not going to have a calculator to do fractions for you. And there it is. And I feel really bad because, well, I think I'm dancing on her grave at this point. All right, this is going to be harder. Identify the X-intercepts. So what we're going to do here is we're going to set this thing equal to 0. We're going to have 5x squared plus 15x, okay, minus 2. I don't think I can factor this. I think 5 times negative 2, right? Because my vertex is under the axis, so it is going to cross, right? Vertex is like down, way down here somewhere. So it is going to look something like this. All right, so it is going to cross. Just don't know what tools they're allowed to have right now. Because 5 times 2, that's negative 10. Can I think of anything that adds up to 15 while getting negative 10? And not really. So I wonder if they, I want to cheat. I want to know if they're going to let us do that. Let me check something at this point. Because the only way I can think about what we need to do there, because I can't factor that, is we're going to have to use quadratic formula. Okay. I don't want to complete the square on this because the first term is not going to be friendly. But I don't know if we know the quadratic formula yet. All right, well, let's assume that we do, because the only way I can get this X-intercepts here is to use quadratic formula, so I think we're stuck. So, important thing about the quadratic formula, right-hand side must be 0. Okay. It only works for quadratics. Hence the name. Okay, so we're going to say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you search YouTube for quadratic formula songs, you will find a quadratic formula to the tune of Pop Goes the Weasel. Best of luck getting that out of your head ever again. But on the other hand, is when you're stuck in a test, you're nervous, you're like, what's the quadratic formula? Negative b plus or minus, and you won't be able to get it. Okay, so there it is. I can't do justice to singing that, so I'm not going to. Okay. So negative b, 15, b squared, 15 squared, minus 4. A was 5, c is minus 2. All over 2 times 5, 2a. Okay. So x equals negative 15 plus or minus the square root. 15 squared is 225. Minus, actually, how many minus signs do we have here? We have 1, 2 minus signs. By the way, if you're not used to doing quadratic formula yet, maybe this is the first few times you've done it. Right there, that's the mistake everybody makes. Okay, they misplace the signs and they forget that. Okay, so that's going to be what? That's going to be 10 times 4 is 40 divided by 10. Right? So this is x is equal to negative 15 plus or minus 265 all over 10. Okay, can we go fishing inside of 265? What is 5 in the 265? It's 5. 25 there, it's a 1, that's a 5, there's 3, and that's great. That's 3 times 15. We got nothing. There's no simplifications we can have here. So we're stuck, all right? So we're going to say x equals negative 15 plus root 265 all over 10, and x equals negative 15 plus, minus 265 square root all over 10. Those are your x-intercepts. I know they look delightful, but that's what they are. Okay, we're stuck with that. Right? We'll definitely do another one of these because I want to make sure that you guys got this. This is one of these skills you're supposed to learn. Okay, can we plug this in a calculator? Yeah, sure. So negative 15 plus square root 265. Hit the equals button because it's all over 10 divided by 10. Okay, so x equals negative 1.947. And then let's look at the other side. So we have minus 15 minus the square root 265 equals divided by 10. So we have x equals negative 3.127. We'll call it 8. Right. Here's a cute little trick. If you average these two numbers, you'll get the vertex. So 1.947. Yeah, these are all negative. You have to remember. 3.128 divided by 2. I got 2.5. What am I supposed to? Oh, I think that's not right. What did I do wrong? All right, let's not worry about that. Here's our x-intercepts. Y-intercept, thankfully, something easy. Okay. So y-intercept, we just go ahead and we say, well, let's go ahead and do this. So this is 5 times 0 squared, right? Plus 15 times 0, minus 2. 0, 0, minus 2. And this just gets the function, axis of symmetry, and all the other fun stuff. So state whether it goes up or down. This one went up. Identify the vertex. Let's go back and do that. Right, what did we do? We said this was negative 15, right? All over 2 times a. That's negative 15 over 10, 3 halves. Negative 3 halves. And what did we come up with on our calculators for the y part? We said that was negative 83/4. I wonder if it'll take it. That didn't like it. What didn't we do? Let's see, when we plug this thing in, we might have to double check this. So 5 times 3 over 2. Oops, 3 over 2 squared. There we go. All right. Plus 15 times negative 3 over 2 minus 2. I think that's still a negative 13.25. That's better. Determine the x-axis. See, here we go. You have parentheses. Okay, so write them as an ordered pair. They didn't make us do all of that. They must have expected this to happen. Okay, so we're going to say this is going to be fraction negative 15 plus the square root of 265 all over, what was it, 10? Not 110, just 10. Y value was 0, comma, parentheses, ordered pair. And then again, we're going to have fraction negative 15 minus square roots 265 all over 10, 0. I guess they really wanted us to use that. Determine the y-intercept. Ordered pair. 0 minus 2. Sketch it. Oh, thanks a lot. At least they gave us this tool. Okay, they gave us this tool. So let's go ahead and place the vertex. Let's not do that. We're gonna hit that first. Okay, what was our vertex? Our vertex was 3 halves, negative 3 halves. And then we had negative 13.25. And we're going to plot that point. So there it is. Now we will place the vertex. Okay, choose how the curve opens. It opens up. Pick another point. Well, we had a 0, negative 2, didn't we? Otherwise, I would have had to use my little tool there to do 2 points. So I'd have something to aim to. All right. And if you picked a different point, that would be fine. Okay, but I would encourage you to always use zeros if you possibly can. To find the axis of symmetry, x equals negative 3 halves, because they told us we know what the vertex is. We're good. Okay, function g has a, I'd say it's a minimum. Okay, a minimum value. Okay, the minimum value of g is negative 13.25. And then write the domain and range. Okay, again, it's very, it's very redundant. It repeats a lot. Okay, and the range was negative 13.25 and off to infinity. All right. So there we go. Which one is this? This was 9. All right. Let's see. I think we should probably try one more of these. Okay. So let's see here. All right, here's our function. 3x squared minus 15x minus 4. Right. It's going to open up. Right? We're going to get that kind of a shape. Okay, because the first coefficient is positive. That's how we know that. Okay, identify the vertex. Well, that's where x is equal to negative b over 2a. Okay? So that's going to be negative 15 over 2 times 3. Okay, so it's going to be 15 over 6. Let's see, we can cast out a 3. That's going to be 5 halves, yeah? Okay. 3 times 5, that's 3 times 2. So, oh, nope, this is 3 times 5 over 3 times 2. Oh, yeah, okay, 5 halves, we're good. Okay, the negatives canceled out, we're set. Okay, now the y part, we need to do n of 5 halves. So that's going to be 3 5 halves squared minus 15 times 5 halves minus 4. Right? I have 3 times parentheses 5 over 2 squared minus 15 times 5 halves minus 4. Okay, just like you see it there. I might put parentheses around this. There we go, negative 22.75. Again, we could make it fancy. Negative 91/4. Okay. All right. Determine the x-intercepts. Get easier said than done, right? They're going to say, oh, find the intercepts like it was nothing. So we have 3x squared minus 15x minus 4 is equal to 0. Well, that's 12. Nah, I can't make it out of 15. Can't do it. All right, so we're going to say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is 15 plus or minus the square root 15 squared. If I do negative 15 squared, it's going to be positive when I'm done anyway, right? So that negative doesn't really matter. Minus 4 times 3 is negative 4. All over 2 times 3. All right. So here we're going to have, we have x equals 15 plus or minus 15. That's just 15, 225, right? Okay. Negative times a negative, so we get 12 times 4, so plus 48. All over 6. So we have 15 plus or minus the square root, 225 plus 48. I know, I apologize. These are awful. 273, all divided by 6. 273 divided by 3. And we're stuck. 91 doesn't anything. So, actually 91 is something. Yeah, because it's 100 minus 9. So 10 minus 3, 10 plus 3, so that's going to be 7 times 3. That doesn't help. Okay. So there we go. we have x equals 15 plus root 273 all over 6, and x equals 15 minus root 273 all over 6. 0, 0. That's where y is 0. Okay. Now, when they ask you, for the other intercept, I'm like, what about the y-intercept? Like, thank you. X equals 0. So we go back into this thing, x equals 0. That's going to be 0, negative 4. All right, that's a nice one. All right. And then we can go through and do sketch the function. We'll do that. I'll tell you what. I should have watched the time before I started this one, because I don't want to keep us to past everything that we have here. And we started a little bit late, but not the kind of late that's going to finish doing this. So we'll start off with another one of these tomorrow. So we'll be able to have more fun with quadratic formula and do all the rest of this bit in here. Okay. So let's go ahead and close this, and we will see you tomorrow night. So I'm going to stop recording.